Okay, we're going to keep zooming on through here. We're going to start with topic 8, right where we left off, and this is finding slope and relative extrema, or slope relative error, sorry, using linear approximation. So this kind of carries on this last one. They're saying, is the approximation an overestimate or underestimate? So essentially, the best way to do this is to get your tangent line, and then you look at whether the graph is decreasing and concave down, decreasing concave up. So like if it's decreasing, or this one's increasing and concave down. So that means if you use the tangent line, it would be an overestimate because it would be above the line. If you used it right here, it's too big. Whereas if it were increasing and concave up and you make your tangent line, that's an underestimate of the function. So it all has to do with this whole estimating using the tangent line. And I think if you make a picture, it's something you don't need to memorize. It's something you work through your skills. Mean value theorem, big concept. It shows up in velocity, average velocity, acceleration, shows up in just directly mean value questions. And I know we did some hand motions with this that helped you distinguish between mean value and rolls, but really they're really the same theorem, just rolls is more of a special case. So what that means is if you have this function here, you take the slope of that function using the old-fashioned slope, f of b minus f of a over b minus a. Somewhere, if this is continuous and differentiable, somewhere there has to be a slope right here that matches that slope. The derivative equals the value. So this shows up in a whole bunch of different ways, and we'll work through some of these together in class and examples. But the average rate of change, the slope of the secant line, somewhere equals the instantaneous rate of change, which is the derivative. Big concept. And note when you see it, when they're giving you points, you can find average slope or average rate of change. When they give you a function, you can find the derivative, or if they give you a tangent line, you can find the derivative. So there's a whole bunch of applications. There's a few you can work through here. I'll work up some examples for you to take a look and check the answers. Okay. Extrema on a closed interval. Key here, we've talked about testing for maxes and mins and all that stuff. The key here is if you are taking absolute extrema, you need to have a table, and all you need to do is check the y values or the f of x values at your endpoints, whatever those are, and then the middle, you need to check the y values at any turnaround point. So remember that if you have a little interval that does this, we have a relative max right here, and depending on how much this turns out, we might have a relative min right there, but the absolute max could happen at the endpoint. So with absolute, remind yourself, endpoints. I need to test the endpoints, and then I test my regular parts where the derivative is 0 in the middle, because those are the relative, and they could be that you could have a situation where it's like this, and this time the relative where the derivative is 0 is the biggest in that interval. It just depends. Lots of terms with maxes and mins. Critical points, increasing, decreasing. Be careful when they say something like increasing, then f prime is greater than 0. If they say that the velocity is increasing, that would be like saying the derivative of the first derivative, so that would be the second derivative. The velocity is increasing, your acceleration is positive. Whenever it says justify, which is almost every time that you're not doing a multiple choice question, the way you justify maxes and mins is you just say where the slope changes. If you know what the slope is, you can talk about that, but basically minimums occur when the slope changes from negative to positive, maximum from positive to negative. Same with points of inflection. These are all critical terms underneath the slope and concavity section. Usually when we're talking about the derivative or the second derivative equals 0, also undefined. But again, this and has a sign change. Has to have the sign change. You have to test it. Concave up means the second derivative is positive. Concave down, second derivative is negative. Concave up is the curve is facing up. Concave down, the curve is facing down. We spent a lot of time on these. I will work on an answer key to have so you can check this later on. I'm just giving you the brief overview. Second derivative test. The first derivative test is one we usually use. The second derivative test is an alternative method that, especially with tables, if there's table questions, but there's other times as well. Once you find your critical numbers, so where the derivative is 0 or undefined, you can test those by putting them in the second derivative. If you get concave up, then you know you have a min. If you get concave down, you know you have a max, because the first derivative being critical number says you could have a max or min. If you don't get either, if you get 0 there or undefined, then the second derivative test doesn't work. Okay. Curve sketching, you're good. We're going to skip that. It's using the information that you have to keep going and make nicer sketches. Okay. Pardon me, I don't have a cough button. More to do with curve sketching. What you might want to pay attention to is comparing the three graphs. So the graph of the derivative, remember, we are only worried about whether it's positive or 0, positive, 0, or sorry, positive, positive, negative. Okay, so if that is the graph of the derivative, how would that relate to the graph of the original function? That means the original function would be increasing, then 0, then increasing, then 0, then increasing. We're not looking at the slope of the slope. Okay, but the concavity of the original graph would be affected in a different way. So the concavity, this would be concave up, 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 0, up, 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 0, down, 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 down. So those two things mean different items for the original f of x. Depends on what you're looking at. Usually, they're going to give you the graph of the derivative. That's generally what you're going to be looking at. And you're going to look at the original function and the second derivative from there, or you're going to take the area under the curve. Slope and concavity from a graph. These are just some problems that you can work out reading. General and multiple choice kind of questions is where this comes from. And they will be in the form of a usually like 3 statements, and they'll say, is statement 1 true, is statement 2 true, is statement 1 and 2, statement 1, 2, and 3, none of them, all of them. So don't look at the multiple choice pieces when you're doing it. Break it down into parts. Figure out what you have in intervals. Like if this is the original function, you know it's increasing here, decreasing here, increasing here. It's concave down, concave up, concave down. It kind of helps you break that down. I will go through and make a key for these. These are not as big of concepts that you need to know. We will start here on the next video with the table problems.